Hi, I'm Rami Tamimi, and welcome to my new office. This will be the space that I kind of work in from now on. I hope you guys like it. Today we will be calculating the coordinates of our survey traverse. Alright, if you haven't seen the last video, I recommend you click on the eye in the corner, watch and see what the field procedure is like, what goes into the data collection, all the different setups that we had. Then come back to this video and we'll calculate all those coordinates using one reference point. Alright, I'm gonna go ahead and direct our attention to the computer so we can see all of the data that we collected. Right here we have a sketch of our work, and here are all the numbers that we measured in the field. If you recall, we initially set up on pink, we then back-sighted the reference point and four-sided green. Then we set up on green, back-sighted pink, four-sided red, then set up on red, back-sighted green, four-sided blue, set up on blue, back-sighted red, and four-sided orange, set up on orange, back-sighted blue, four-sided pink, and finally set up on pink, back-sighted orange, and four-sided green. Between all of these points we have angles and distances referring to the internal angles of our traverse. You're also going to notice that there is a forward distance and a backward distance. The forward distance are all of the distances that we took when we were taking a foresight, and the backward distance is all the distances that we took when we were reading a backsight. We then take the average of these two so we can increase the level of accuracy with our distances, which is what we see right here. Now the first step is going to be to add up all of our internal angles so that we can calculate what our misclosure is. Not all these measurements are internal angles, everything except for the first one is, because remember, that angle is this angle right here, and that's not necessarily, going from one line to the other. That's why we measured this last one right here, which is actually from here to here. So just disregard this angle right here when we're adding up our angles. The best way to add up your angles is by using this calculator. Have you bought this calculator yet? If you haven't, click the link in the description to buy this Casio calculator. This is not a sponsored video. I'm not being paid by Casio. I just don't want you to be using a graphing calculator that you're not allowed to use on your NCEES licensing exam. This is approved by NCEES for all licensing exams. So practice on it, learn it, become best friends with it so that you can use it on your exam. All right, I'm done ranting. So we're gonna go ahead and add up all of our angles. 67 degrees, 17 minutes, 47 seconds, plus 217 degrees, 40 minutes and 20 seconds, plus 70 degrees, 4 minutes, 46 seconds, plus 48 degrees, 9 minutes, 53 seconds, plus 136 degrees, 47 minutes and 39 seconds. And we get a total of 540 degrees, 00 minutes and 25 seconds. Now remember, to calculate misclosure, it is error divided by number of angles. So that is going to be 25 seconds over 5 angles, because we have 1, 2, 3, 4, 5, gives us an error of 5 seconds per angle. So because we're 25 seconds over, we're going to then have to subtract 5 seconds from every angle. So now this one will become 67 degrees, 17 minutes and 42 seconds. This one is 217 degrees, 40 minutes and 15 seconds. 70 degrees, 4 minutes, 41 seconds. 48 degrees, 9 minutes, 48 seconds, and 136 degrees, 47 minutes, 34 seconds. So now we have 540 degrees. If you're ever unsure about what your angles are supposed to add up to, the formula for figuring out internal angles is 180 times n minus 2, where n is number of angles. So in our case, 180, 5 minus 2 is equal to 540. Now that we have our adjusted angles, we're going to be using them to calculate our azimuths. This is going to be a little tricky and it's a little bit tedious, but bear with me, we'll get through this. Let's refer to our sketch to give us a better idea of what we're doing. The most important thing with a sketch is the north arrow. This north arrow will indicate exactly where you are in terms of orientation. Knowing where you are will help determine the location of your next point. So we know that the north arrow is pointing up. By knowing our orientation, this will help us determine where we're going to get to the next point. I want you to think about it like this. I'm gonna draw something like this at every one of these points. So when we look at our quadrant system, you see we're heading in the northwest direction, meaning that our azimuth needs to be above 270 degrees. Because remember, this is north and this is west. Now in the last resection calculations video, we had determined the azimuth between the reference point and pink. In that video, I called it like the total station setup point and the unknown pink point, something like that. It's the exact same points, I just changed the name of those points. Go ahead and refer to that video if you want to see how we calculated the azimuth between these 2 points. But we're going to use that azimuth as a reference to determine the azimuths for the rest of our points. If you guys recall, that azimuth was 99 degrees, 35 minutes, and 4 seconds. Now we want to determine the azimuth here. If we're going to take a look at the reference point and where this 99 degree is, it lies in this area. This is a bit exaggerated, but you get what I'm saying. To figure out where that line is on point pink, we need to then take the back azimuth of that point. To determine the back azimuth, we need to add 180 degrees. So we're going to start with our reference azimuth, add 180 degrees to it, and then we measured the angle from here to here, 67 degrees, 18 minutes, and 26 seconds. So we will add that as well, and that will give us our azimuth from pink to green. So the azimuth to green is the reference azimuth of 99 degrees, 35 minutes, and 4 seconds, plus 180 degrees, so that we get the back azimuth of it, plus the angle measure of 67 degrees, 18 minutes, and 26 seconds. And that gives us 346 degrees, 53 minutes, and 30 seconds. Okay, same process now. We're going to then again draw up this shape. You can see that the line is in the southwest quadrant, which means our azimuth needs to be greater than 180 degrees, but less than 270 degrees. We have this azimuth, and we have this angle measure, which is adjusted at 67 degrees, 17 minutes, and 42 seconds. Now, what we have from pink is this azimuth right here. If we were to take the reverse azimuth that comes down here, we would need to subtract 180 degrees. So if we take our reference azimuth, subtract 180 degrees, and then add our measured angle, that'll place us right here. So to get to red, we need to take our azimuth of 346 degrees, 53 minutes, and 30 seconds. We will then subtract 180 degrees to get the back azimuth, and then we will add our angle measure of 67 degrees, 17 minutes, and 42 seconds, and that gives us 234 degrees, 11 minutes, and 12 seconds. Let me bring this down one line so that it's a little bit cleaner for you guys. Now this right here is the azimuth to red. Let's head back up here and look at the next point. We look back here and we see we want this azimuth, so we need to subtract 180, because what we have right now is this right here at 234 degrees. So if we subtract 180 from that, we'll end up on this line right here. And then we have an angle measure from here until here when we zeroed out our backside at green and then measured blue. So taking the reference point, subtracting 180 to get the reverse azimuth, and then adding our angle measure. So that is 234 degrees, 11 minutes, and 12 seconds minus the back azimuth, so 180 degrees. And we're going to then add the angle of 217 degrees, 40 minutes, and 15 seconds. And that will give us 271 degrees, 51 minutes, and 27 seconds. Now let's look at the setup of blue, and when we draw in our thing, we see it's the same situation. I mean, we are coming out here with an azimuth, we need to go back azimuth, so we're gonna subtract 180 degrees to get us on this line, and then we have this angle measure here, so all we have to do then is just add that angle measure. To get to orange, we do 271 degrees, 51 minutes, and 27 seconds, minus 180 degrees, because we have to measure that back azimuth, and then we're gonna add 70 degrees, 4 minutes, and 41 seconds, and that gives us 161 degrees, 56 minutes, and 8 seconds. Now we are set up on orange and we want to get to pink. This is a little bit strange because now we have the azimuth coming down. We need to then add 180 degrees to get back. It will be the azimuth of this line coming back. We're going to add 180 degrees because what we have right now from blue is coming down like this. So we want to get to the other side of it. Then we're going to add the angle measure, which is from here to here. But the problem is we're crossing the 360 degree mark, and there are no angles above 360 degrees. Anytime you go over 360 degrees, subtract 360 from it. Always do that because you can't go above 300. You can't be like, I'm at 400 degrees azimuth. No, like you subtract 360 from the 400 and then you're at 40 degrees azimuth. So make sure we do that. We're gonna subtract 360 degrees from our end total because we're gonna go over 360 since we crossed the 360 line, or the north line if you wanna be more technical. Setting this one up, it's gonna be to pink, 161 degrees, 56 minutes, 08 seconds. Where we're going on the back azimuth, but we're on the opposite end, so we're gonna add 180 degrees. We're gonna add the angle measure of 48 degrees, 09 minutes, 48 seconds. Then subtract 360 degrees from that, and we will have 30 degrees, 5 minutes, and 56 seconds. Last one, almost done. We're setting back up on pink. Once again, we have the back azimuth. Now, since this is coming up here, we are then going to add 180 degrees plus our angle measure from here to this line right here. So now we're going back up to green, and this is just so we can get the internal angle, nothing more. Maybe it'll help us check our coordinates, but 30 degrees, 5 minutes, and 56 seconds plus 180 degrees plus 136 degrees, 47 minutes and 34 seconds is equal to 346 degrees, 53 minutes and 30 seconds. Hey look, that number matches this one. We did something right. Okay, now that we have all of our azimuths, the next step is going to be to calculate the latitudes and departures between the points. Latitude and departure is defined as the distance that is traveled in each direction, being northing and easting. Latitude is associated with northing, departure is associated with easting. Northing is equal to latitude, easting is departure. And we use this to find the difference between coordinates to then verify where the location of coordinates are. The formula to calculate latitude is always going to be the distance times the cosine of the azimuth. And to calculate departure, it's always going to be distance times the sine of the azimuth. So we're going to use these formulas to calculate all of the latitudes and departures for all of our points. I've set these equations all up based off of this formula. For pink, 35.51. For green, we get negative 11.98. For red, we get negative 25.89. For blue, we get negative 18.99. For orange, we get 27.46. For pink, we get 29.57. And for green, we get negative 11.98. Now you might be asking, why is it that green is the same but pink isn't? So this right here is the change in how far we're going in the x direction between points. When referring to pink the first time, the change is coming from the reference point because that was the first point we backsighted to. But looking at pink the second time, we're coming from orange. So the change is coming from orange. With green, both times we were backsighting pink. That's why the change is the same, because it's from the same point. I'm gonna go and erase these answers, and I'm gonna erase the word sine here and replace it with cosine. Right, cosine on all of these. And this no longer is easting, this is now going to be the northing. So now we're going to calculate the latitudes, which is the change in the y direction between each of these points. However, instead of using sine, we're going to use cosine. And when I do this, we get, for pink, a negative 5.99. For green, we get 51.42. For red, we get 18.68. For blue, we get 0.62. For orange, we get a negative 84.22. For pink, we have 51.02. And for green, we have 51.42. Same situation here with pink and green. Pink is going to be different because it's referencing a different backsite. Green will be the same because it's referencing the same backsite. Now we're going to go ahead and add up the latitudes and departures so that we can figure out our error. You're only going to be adding up the ones inside of the traverse. Anything that's referring outside of the traverse or is repeated, we're not going to include. So since the first point is referring to the reference point, that's not a part of the traverse. That's just to set up our orientation. And this last green right here is not a part of the traverse either because we already included it up here. So you're going to be adding up these departures and you're going to be adding up these latitudes. In the departures, I ended up with 0.17, and in the latitudes, I ended up with 0.16. Usually your error between latitudes and departures should be very similar, like within like a couple hundredths of a foot. If you've got a lot of error in one and not a lot in the other, then you might have done something wrong, but usually they come out pretty close to each other. To make this correction, the same formula as before, error divided by number of angles. So with the first one, we have 0.17 over 5, and that is equal to 0.034. In the second one, we have 0.16 over 5 is equal to 0.032. So because we're over, we're going to subtract this number from all of the latitudes and departures. Now let's take a look at green. Now because we're at a negative 11.98, we're then going to subtract 0.034, and that will give us a negative 12.014. All right, let's do it for the rest of these. For red, we will have a negative 25.924. For blue, we'll have a negative 19.024. For orange, it'll be 27.426. And for pink, it will be 29.536. Now over at the latitudes, green is 51.388. Red is negative 18.712. Blue is 0.588. Orange is a negative 84.252. And pink is 50.988. And now when we add all these up, we should have no error in our differences between departures and latitudes. Alright, now you've got your adjusted latitudes and departures. We're going to use this information to now calculate the coordinates of all of our points. To calculate coordinates, all it is going to be the reference northing plus the latitude gives you the pink northing, and the reference easting plus the departure gives you the pink easting. Then what you're going to end up doing is using the pink northing plus the new latitude will give you the green northing, and the pink easting plus the departure will give you the green easting, and so on and so forth. You're just going to keep using the last coordinate and adding the change in latitude and departure to the northing and easting respectively to get the new coordinate. So the easting plus the departure is 1351706 4.82. Taking the northing of the reference point and adding the latitude, which is a negative 5.99, I get 42033.61. Now I'm going to take the easting of pink and add the departure, which is a negative 12.014. And I get the easting of green is at 13517.052.81, and the northing, we're going to add this latitude. So we have 420.385.00. Now we're going to use this easting plus this departure to get the easting of red. I get 1351726.88. The northing 420.366.29. Now the easting of blue 135170007.86. The northing of blue is now 420.366.88. Now the easting of orange is going to be 135170035.29. The northing is going to be 420.282.63. The easting of pink is going to be 1351764.82. Notice how this easting is the same as this easting. The northing is now going to be 420.333.61, and the same thing here, the northing is the same up here. And we're going to calculate green, and that's going to be 1351752.84. We have a difference here of 3/100ths of a foot, and we're gonna have 420.385.03. Same thing here, 3/100ths of a foot. And that is how you calculate the coordinates of your traverse. And with that, I'll see you next time.